Welcome to Mind to Your Learning, where we make GCSE learning and revision simple. So far, you may have worked with straight line graphs. Today, we're moving on to curves. Quadratic graphs are important because they appear in algebra, graph sketching, real-world modelling, and problem-solving questions. By the end of this lesson, you'll understand the shape of quadratic graphs, how to complete a table of values, how to plot a smooth curve, and how to identify key features like the turning point and line of symmetry. Before we begin, remember to like this video, subscribe to Mind to Your Learning, and follow along carefully. By the end of this lesson, you should be able to recall the properties of horizontal and vertical lines. You will recognize the characteristic shape of a quadratic graph. You will complete a table of values for a quadratic equation. You will plot points and draw a smooth parabola. Finally, you will identify key features of a quadratic graph, including the turning point and the line of symmetry. The key idea today is that quadratic graphs are not straight lines. They are curves called parabolas. Let's begin with the key vocabulary. A quadratic is an equation where the highest power of the variable is 2. This usually means it contains an x squared term. A parabola is the U-shaped or N-shaped curve made by a quadratic graph. The vertex is the turning point of the curve. It is where the graph changes direction. Symmetry means that one side is a mirror image of the other. These words will help us describe quadratic graphs accurately. Before we move to curves, let's quickly recap special straight lines. Horizontal lines have equations like y equals a. Every point on a horizontal line has the same y coordinate. For example, on the line y equals 3, every point has a y coordinate of 3. Vertical lines have equations like x equals b. Every point on a vertical line has the same x coordinate. For example, on the line x equals -2, every point has an x coordinate of -2. Horizontal lines have a gradient of 0, while vertical lines have an undefined gradient. Let's do a quick recall check. Question 1. What is the equation of a horizontal line passing through the point 5, -4? Question 2. What is the equation of the y-axis? Question 3. Does the line x equals 7 pass through the point 7, 10? Pause the video and try these before checking the answers. Let's check the answers. For question 1, the horizontal line passing through 5, -4, has equation y equals -4. This is because every point on that horizontal line has y coordinate -4. For question 2, the equation of the y-axis is x equals 0. Every point on the y-axis has an x coordinate of 0. For question 3, yes, the line x equals 7 does pass through the point 7, 10, because that point has an x coordinate of 7. Now, let's think about why we need curves. Not everything in the real world can be modelled with a straight line. If you kick a football, it does not travel in a straight line forever. It rises, slows down, reaches a highest point, and then falls back towards the ground. That curved path is similar to a parabola. To model this kind of shape mathematically, we use quadratic equations. So quadratic graphs help us describe curved relationships. They form a curve called a parabola. A quadratic equation often looks like y equals ax squared plus bx plus c. The important part is the x squared term. If the x squared term is positive, the graph is U-shaped, a bit like a smiley face. If the x squared term is negative, the graph is N-shaped, a bit like a sad face. So, the sign in front of x squared tells us whether the graph opens upwards or downwards. To plot a quadratic graph, we usually start by creating a table of values. Let's look at the graph of y equals x squared minus 3. We choose different x values and calculate the matching y values. If x equals negative 2, y equals negative 2 squared minus 3. Using brackets, negative 2 squared is 4. So y equals 4 minus 3, which is 1. If x equals negative 1, y equals negative 1 squared minus 3. That gives 1 minus 3, which is negative 2. If x equals 0, y equals 0 squared minus 3, which is negative 3. If x equals 1, y equals 1 squared minus 3, which is negative 2. If x equals 2, y equals 2 squared minus 3, which is 1. Notice the symmetry in the values. 1, negative 2, negative 3, negative 2, 1. Let's check your calculation skills. For the equation y equals x squared plus 2, when x equals negative 3, what is y? And when x equals 3, what is y? Use the word bank to help you. Pause the video and calculate both answers carefully. Remember, negative 3 squared means negative 3 times negative 3, which is positive 9. The answer is 11 for both values. When x equals negative 3, y equals negative 3 squared plus 2. Negative 3 squared is 9, and 9 plus 2 equals 11. When x equals 3, y equals 3 squared plus 2. 3 squared is 9, and 9 plus 2 equals 11. This matching result is not a coincidence. Quadratic graphs often have symmetry, so opposite x values can sometimes give the same y value. Once you have your coordinates, plot them carefully as small crosses. With straight-line graphs, we use a ruler to connect the points. But with quadratic graphs, we do not use a ruler. A parabola is a smooth, continuous curve, so you should draw a smooth curve through the points. Also, look for symmetry in your points. If the graph looks lopsided when it should be symmetrical, go back and check your calculations, especially the negative x values. Now, let's look at the turning point. The turning point, also called the vertex, is where the graph changes direction. For a U-shaped parabola, it is the lowest point. For an N-shaped parabola, it is the highest point. In our example, y equals x squared minus 3. The turning point is at 0, negative 3. This is the lowest point on the graph, so it is called a minimum. The graph goes down towards this point and then turns back up. Every parabola has a line of symmetry. This is a vertical line that passes through the turning point. If you folded the graph along this line, the two halves would match perfectly. For basic quadratics like y equals x squared plus c, the line of symmetry is always the y-axis. The equation of the y-axis is x equals 0. So for y equals x squared minus 3, the line of symmetry is x equals 0. Let's test your understanding. The statement says, the quadratic graph y equals negative x squared plus 5 has a minimum turning point. Is that true or false? Pause the video and think carefully. Look at the sign in front of x squared. Does the graph open upwards or downwards? The statement is false. In y equals negative x squared plus 5, the coefficient of x squared is negative. That means the graph is N-shaped. It opens downwards. So the turning point is at the top of the graph, not the bottom. A turning point at the top is called a maximum, not a minimum. The correct explanation is, because the x squared coefficient is negative, the graph is N-shaped, meaning the turning point is at the top. So y equals negative x squared plus 5 has a maximum turning point. The plus 5 shifts the graph upwards, but it does not change the fact that the graph opens downwards. Now let's spot a common error. A student calculates the table for y equals x squared plus 1. For x equals negative 2, they write y equals negative 3. For x equals 2, they write y equals 5. What have they done wrong? Pause the video and think about how negative numbers should be squared. Also think about how this mistake would affect the shape of the graph. The student has not squared the negative number correctly. For x equals negative 2, the calculation should be negative 2 squared plus 1. Using brackets, negative 2 squared is positive 4. So, y equals 4 plus 1, which is 5. The student probably typed negative 2 squared into a calculator without brackets, which can give negative 4, then plus 1 gives negative 3. This mistake would make the graph look lopsided instead of symmetrical. A quadratic graph like y equals x squared plus 1 should be symmetrical about the y-axis. You should now be able to recognize quadratic graphs, complete a table of values, plot a smooth parabola, and identify key features like the turning point and line of symmetry. Remember, if the x squared term is positive, the graph opens upwards. If it is negative, the graph opens downwards. If this lesson helped, please like the video, subscribe to Mind Tier Learning, and watch the next GCSE Maths lesson to keep building your graph skills.